A'udhu billahi minash shaitanir rajeem. Bismillahir rahmanir rahim. In the name of Allah, the most beneficent, the most gracious, the most merciful. This is Engineer Faisal Ijaz, and today I am presenting a lecture on the topic vacuum technology, and also I want to introduce my channel with entitled Chemical Engineering Edge Tech. Also different topics of chemical engineering discussed by me, which you can see at the background pages. And if you people will subscribe my channel, then you will get my latest videos. Today our topic is vacuum, and we will discuss some fundamentals of vacuum technology. So we will start from the basic definition of vacuum, and according to general definition, vacuum meaning empty space. Vacuum is a Latin language word of meaning empty, and that empty meaning is not only empty from solid or liquid but also from gas. If we proceed to scientific definitions of vacuum, all have same concept of vacuum, which is lower pressure than atmospheric. But for more understanding, we visit these definitions. According to scientific definition, vacuum is a pressure but must be lower than atmospheric pressure. So atmospheric pressure is a reference, and if we are talking about vacuum, we will take our discussion always below atmospheric pressure. And you people know well about atmospheric pressure, which is 1 atm. So for vacuum pressure, one condition is important, that vacuum pressure must be in an enclosed area. According to second definition, a space in which the pressure is significantly lower than atmospheric pressure. So it's also have the same concept which we have discussed already, that vacuum pressure is always lower than atmospheric pressure. So according to third definition, a condition in which the quantity of atmospheric gas present is reduced. It's mean that we reduce atmospheric pressure of gas with the help of any equipment like a vacuum pump, and we will reduce that pressure till its effect become negligible. The next is why vacuum. So to understand the concept of vacuum, you can observe in the both diagrams that blue circles are indicating the gas particles, and the sign of arrow indicating the free path. And so if the gas will be present in the enclosed area, so the particles of gas will collide each other, so the free path will not be available. So in many applications we want a free path, so we remove gas from that enclosed surface. And if we will remove that gas from enclosed surface, the particles of gas will reduce. And in the second figure, in the third part, you can observe only 3 particles of gas are available, and also the free path is only straight. And so we want that free path in many applications like cathode ray tube and physical vapor deposition. So the summary of above diagrams is that if atmospheric pressure will be present, then the surface will have different particles, and if highly vacuum will be created with the help of some equipments like a vacuum pump, then the surface will be clean from particles, and a free path will be available. After concept of why vacuum, we proceed to applications. And vacuums are used in industry and commerce for packing, for drying, and pick and place. Some process engineering operations like distillation, like vacuum distillation, are carried out in a vacuum because low pressure is an advantage on temperature sensitive product. And to know more about it, vacuum is used to control a chemical reaction, in which we can control a rate of reaction and the concentration of reaction, and also it create forces and flows. Vacuum pickup, vacuum cleaners are some domestic applications, and now you can understand why we create vacuum. Now we will talk about the pressure ranges of a vacuum, and in this table two things are indicating, which is range and pressure. So if we go below then atmospheric pressure, then we will attain different levels of vacuum, and just after below atmospheric pressure we will attain just low vacuum, and after that we will attain high vacuum, and after that we will attain ultra high vacuum. You can see the different ranges of all these levels which are indicating here, and the unit which is used is millibar, and 1 millibar is equal to 0.014538 pound per square inch. It's mean PSI. Now you people know that vacuum have different levels, in which low level vacuum, high level vacuum, and ultra high level vacuum. So different technologies are used to produce these all levels of vacuum. So now we go to production of that all levels of vacuum. So in this diagram you can see at the right side high vacuum pumps. So these are some pumps enlisted here to create high vacuum pump, so in which turbo pumps, cryo pumps, diffusion pumps, ion pumps, and at the left side you can see here some vacuum pumps are enlisted, in which rotary van, scroll pump, diaphragm pump. These pumps are also used to create vacuum. So you know these types of pumps, and but many of you people don't know about cryo pumps, diffusion pumps, ion pumps. So I just give you introduction of these pumps. So in the first diagram you can see that as a cryo pump, and if you want to know the detail about it, then you can stop that video and can read the all data about it. So we go to next, and the next is a diffusion pump. Also it create a vacuum and high level vacuum. So the next one is ion pump, and that pump also create vacuum. Pump operating ranges, and you people know that vacuum is created by different types of vacuum pumps, and all these pumps have different ranges and different capacities. So in this diagram, under each level of vacuum different lists are available of vacuum pumps, and at the bottom different ranges of vacuums are available. You can observe and you can match for which type of level, which type of pumps are used. The next step is, after production of vacuum, how we will measure that level of vacuum. So in this diagram all the devices are available for different levels of vacuum. So you can observe which type of device is used for what type of vacuum level. So at the end I am presenting some industries where vacuum is used, and these industries are pharmaceutical, semiconductor, aircraft, automobile, glass industries, printing industries, packaging industries, chemical industries, food processing, and confectionery industries, breweries industries, distilleries, plastic, garments, leather, textile, paper, sugar mill, power plants, furnaces, cement industry, fertilizer industry, metallurgical industries, and many more like extrusion process, like priming, like dehydration, filtration, sterilization, tiles, and ceramics industries, and host of the industries application.